Question today is, ready? Here we go. Write this down. What are the different, this is 9-1. What are the different types of slope? And how do I find slope from a table? Rate of change is the exact same thing, is also known as slope. Is it just a different way to say it? So when we talked about steepness, and I talked about like that guy skiing on a mountain, that's a slope. So when we talk about rate of change, sometimes you'll hear me call it rate of change, sometimes you'll hear me call it slope. You have already found slope in this class. We're going to get a little bit more detailed. So ways to think about slope. First way is rate of change. How the table or the graph or the equation or whatever, how it's changing. How is it adding or subtracting the same amount over and over? How are the x's and y's adding and subtracting? And then, so that's a phrase you should already know. And then the other way that you should already know is change in y. Does this sound familiar? Okay, should. Change in y over the change in x. So rate of change is the same thing as slope, which is the same thing as change in y over change in x. Sometimes you're going to see me write it if I'm like low on space. You're going to see it like this. Triangle y over triangle x. If you ever seen anybody change the tires, this triangle is just a math symbol, or actually just in the world in general. We can use that to represent change. So if you're abbreviating things, that means change. Okay, can you go up here and add this? It's not just rate of change, it's constant rate of change. That's important. So this should say constant rate of change, not just rate of change. My bad. Because it's linear and they add and subtract the same amount over and over. You already know how to do this. Here's the thing, you don't really need to find how it's changing for the entire table. Since I'm telling you that these are linear, they should be the same over and over, okay? So it's going to go from 10 to 8. How's it go, guys? -2, okay? If you keep checking it, does it do the same thing? Yes. Okay, so do we really need to write it out a million times? No. Okay, so let's just go ahead and do the bottom. So the y values from 17 to 14, what's it do? -3. So please write down on your table your change in x and your change in y. Is change in y, see I'm just abbreviating, over the change in x. Guys, how do my y values change? -3. How did my x values change? So put that together in a fraction. But here's the thing. Negative divided by negative is a positive. So let's change this to +3/2 and just kind of get rid of those negatives. So our slope is +3/2. So circle positive. This means as x adds 2, what does the y do? Because these are both positive.
Adds 3.
It adds 3. Since it's linear, this is going to happen every single time. As x adds 2, the y always adds 3. The same thing where we find how the x is changing, how the y is changing. So how are my x's going up?
+1.
+1. How is my y going up? Plus 0. Okay. You can do this over and over, but you'll notice that it does the same thing over and over, which should be the case because it's linear. And linear is add and subtract the same amount over and over. So the slope is going to be the change in the y over the change in the x. And I'm going to write this out pretty much every time because I want to make sure I keep it straight, because the biggest mistake that I see is that students will put 1 over 0, top over the bottom. Nope, it's change in y over change in x. So if it's a table like this, it's going to be that bottom number over the top number. So it's going to be plus 0 over plus 1. But we can divide that evenly, so we're going to do that. So what's 0 divided by 1? 0. So we're going to say that's equal to 0.
So it's not 1. That's not negative.
And so is it positive or negative? It's neither. Because it's 0. So I'm going to add a category. And then let's explain what this means. It means that as x adds 1, because that's a change in x, what's the y do?
Add 0.
It adds 0. As x adds 1, I'll say y always adds 0. So let's do the same thing. Find how the x is changing, find how the y is changing. Guys, how's the x changing? Plus 0. It's not changing, right? How are the y's changing? Plus 2. So if we put that together in a fraction, change in y over the change in x, and the y row, I see that it's going plus 2, so I'm going to put that on top. What's happening in the x row? 0. Now, what's any number divided by 0? Incorrect. That's a hard question. Okay, it's actually, this is a weird word. It's called undefined. So any number divided by 0 is going to be what we call undefined. Cookie Monster takes them all. Okay? Undefined. So it is, again, not positive or negative. It is neither. Types of slope. Slopes can be positive. So I'm going to draw the graph version and the table version. Positive would be like this. It's going up. And as a fraction, that would be something like positive 2 over positive 3. Negative would be if the line is going down, and if that's represented by a table, it should have a negative number with it, like negative 3 over positive 2. That's going to be a negative slope. Slopes aren't always fractions. Sometimes you'll see them as just one number, but you can always make that into a fraction. A 0 slope would be if we have a flat line. We'll talk more about that tomorrow. And it's going to be something like 0 divided by 10. So if you have 0 on the top, you can take 0 divided by any number. You have 0 cookies, divide them evenly among 10 friends. Well, no one gets the cookies, right? It's 0. And then the last one is undefined, which would be a line that looks like this. Straight up and down, a vertical line. We'll talk more about that tomorrow. And it's if you have like 5 cookies divided evenly among 0 friends, which doesn't make any sense. And so Cookie Monster gets them all. This is what we call undefined. Okay, it says that we're going to fill in the following tables with the correct integers so that the slope fits the table. The slope is negative 4 over 3, which means, well, again, this is a change in y over the change in x. So the y is going down 4. Oops. No. And the x is going, it's positive, so it's going to go plus 3. So the y goes down 4, every time. The x is going plus 3 every time. So I'm going to zoom out to my table here. All of the x's should go, what are they doing again? Plus 3. The x is on the bottom, so add 3, add 3. This is where it does help to actually do all of them. Add 3, add 3. So we got to fill in the numbers. So you got to keep the pattern. So 3 plus 3 is 6. 9 plus 3 is? And 15 plus 3? 18. Okay. So now it should fit that pattern of adding 3 every time. So the y values are going, what are they doing? -4. So on my table, I'm going to put -4 between all of the values because it's a linear function. It should add and subtract the same amount over and over. So think of your pattern. What number would you have to come from if you're subtracting 4 and you get to 26? 30. 30 minus 4 is 26. Good, good. 18 minus 4 is 14. It is a constant rate of change, the slope of -4/3, and so it is a linear function. I can make this into a fraction. How do I make it to a fraction? How do I make the 2 into a fraction, Elise? 2/1. So if I put 2/1, now it's a fraction. This is still just your change in y over the change in x. So that means since these are both positive, the y is adding 2. Put a plus sign in front. And the x is adding 1. Okay. So we're going to go to our table and fill that in. So the x is doing what again? Add 1. So for all of our x's, we're going to put +1 between the values. So fill in the pattern. 2 plus 1 is 3. 4 plus 1 is 5. So now it should be a pattern of adding 1 every time. For y values, it's going +2. So let's think what numbers this would have to be. What number would have to go before 3? Because 1 plus 2 is 3. So it's going to be 1, 3, 5, 7, 9, 11. Okay.